In this lesson, we're going to apply the rules for exponents to simplify radical expressions. So recall the rules, the properties of exponents. When you notice the base is the same and they're being multiplied like bases, keep the base and add the exponents. If the base is the same and you have it in fraction form, that's a form of division, so you would keep the base and subtract the exponents. Remember the power rule: whenever you have some term raised to a power and it also has a power on the outside, that you're going to multiply the powers. If you have more than one term inside that parentheses, you have to raise both terms to that power. And if you have a fraction, you have to raise both the top and the bottom of that term to that outside power. Recall for negative exponent rule, anytime you have a negative, you have to flip it in order to make it positive. The zero rule, we're not going to probably be working with that, but you should know that, yes, any number to the 0 power equals 1. So let's start here we're going to use the product rule of exponents to simplify these rational exponents. So recall the product rule: if the base is the same, keep the base and add the exponent. So on the first example, they do have the same base of x. So what we're going to do is go ahead and add the exponents. So that's 2/3 plus 4/3, which is going to equal 6/3. And then lastly, we're going to simplify that. 6 divided by 3 equals 2, so the answer is simply x squared. In example 2, the base is also the same. If the base is the same, keep the base of 5. We're going to add the exponents. Now those are unlike terms, so you're going to have to go ahead and combine the unlike terms. To do so, they need to have the same denominator. So on that first fraction, if you multiply both the top and the bottom by 2, then they both will have a denominator of 4. And what that will give you when you finish computing that, you're going to have 3/4. So your answer is 5 raised to the 3/4 power. So this is the product rule. Let's continue. We want to use a product rule and the properties of exponents to simplify these expressions that are being multiplied. So they're actually being multiplied and they have the same base, because if we were to rewrite these from radical form to exponential form, we would see that they would have the same base. And the first one, our base is x. It is raised to the second power. Remember, the power is always on top of the fraction. The plant gets its power from the sun on top. The bottom of the fraction is a root, so you would have 3 on the bottom. So this would be x to the 2/3 power. The second radical, if we convert that to a rational exponent, it's going to be x. You don't see a power here. When you don't see a power, it's understood to be a 1. So that's going to be x to the 1/4 power. So rewriting them as rational exponents, again, notice the base is the same, which is the product rule. If the base is the same, keep that x and add the exponents. So again, the fractions here are unlike fractions. So you'll have to find the LCD and continue to combine that. You can look at my videos on fractions, how to add unlike fractions. But let's go ahead and solve it. When we solve it, we're going to wind up with 11 over 12. So x raised to the 11th 12th is your final answer. Now we're going to apply the quotient rule. Remember, the quotient rule is whenever you have the base is the same, you're going to keep the base of a And what do you do with your exponents? Yes, you're going to subtract your exponents, and it is always going to be top take away the bottom. So that would be 1/2 take away 1/4. Again, these are unlike fractions, so you're going to have to multiply that first fraction, the top and the bottom, by 2 so that they'll have the same denominator, and then only can you combine them. So go ahead and do that process. What you should wind up with when you combine those unlike fractions is a to the 1/4. And so there you have it, using the quotient rule of exponents. Here we're going to still use the quotient rule because it's the same, it has the same base. If you look under the radical, what we need to do here is go ahead and rewrite these radicals in exponential form. So if we look at the top here, this is going to be x to the, let's see what our fraction going to be. It's raised to the 3rd power, so that's going to be on top of my fraction. On the bottom, you don't see anything here. When you don't see anything here is square root. And what index does square root have? Yes, a 2. So the top is going to be x to the 3/2 power. And then the bottom is going to be the very opposite flipped, which is going to be x raised to the 2/3 power. So let's go ahead and rewrite it in the rational exponent form. So it's going to look like so. Now applying the quotient rule, keep the base of x and subtract the exponents, top, take away the bottom. Now again, we have unlike fractions, so you're going to have to find the LCD and combine the unlike fractions. So when we do so, what you're going to wind up with is x raised to the 5/6 power. And there you have it. Now let's move on to the power rule. With the power rule, remember that you must raise every member inside the parentheses to that outside power. So it's going to be s. That's going to be multiplied with 1/4. The power of 4, 4 times 1/4. And then for the t, 8 times 1/4. So we're going to go ahead and multiply those exponents because that's what the power rule says. Now we're going to go ahead and simplify. 4 divided by 4 is 1. So s will have a power of 1, which we don't write the 1, so it's just simply going to be s. For t, 8 divided by 4 is 2. So it will be t squared. So your final answer is st squared. And there we've used the power rule of exponents. Continuing on with the power rule, we have 2 terms in the inside, and we're going to raise both terms to the 1/2 power, which means we're going to multiply their exponents. So with the x, we're going to have 1/2 times 1/2. With the y, we're going to have -3 times 1/2. So let's go ahead and do that. Now we have x to the 1/4, y to the -3/2. Now we can't combine these two because the basis is not the same. One has a base of x, the other has a base of y. All we can do here is to simply apply the negative exponent rule to the y to the -3/2 by moving it to the bottom. And what we have as a final answer is x to the 1/4 over y to the 3/2. And there we've applied the power rule along with the properties of negative rule as well. Lastly, let's do some practice with the negative exponent rule. Recall, you can't leave your exponents as a negative. If you have a negative exponent, recall you're going to have to flip that number and move it to the bottom. So we're going to move it to the bottom, and on top we're going to wind up having a 1. Notice now that our exponent is positive. It is in rational exponent form. Let's go ahead and convert it to radical notation form, the bottom. So recall that the top, the numerator, is the power that we're going to raise the number to. The bottom is the root, and that tells us what root we're going to be dealing with. So 2 stands for square root, so we're going to find the square root of 25, and then we're going to raise it to the 3rd power. So rewriting it is going to look like so. Now we have the square root of 25, which is 5. Multiply 5 3 times, and that's going to give us 125. So therefore, my final answer is 1 over 125. Our last example, here we have a number that has a negative exponent, and again, with negative exponents, you have to flip them in order to make that exponent a positive. So let's go ahead and move that number to the bottom, and we're going to place a 1 up top. Now the fact that we have negative 81 in parentheses, once we write it as a radical, we're going to place the negative underneath that radical symbol along with the number. The bottom here tells us what root we're going to be dealing with. We're going to be dealing with square root, so we're going to have the square root of negative 81 and then raised to the 3rd power. So let's try and see if we can solve the inside here of the radical, the square root of negative 81. We have a problem here, Houston. The problem is, remember that you cannot have a negative underneath an even root because the answer is not a real number, so you can't even raise that to a 3rd power because it doesn't produce an answer. It's not a real number. So the answer to this one is simply not a real number. You cannot do that because here you have an even root with a negative underneath, which is not possible for a real answer, only an imaginary answer, which we will cover in section 10.7. And there you have it. Negative exponent rule.